Hello YouTube, Ian here. Wanted to show you my latest project. It's a little binary clock. I've made a binary clock before that I had on Kickstarter as a soldering kit, and it used old digital logic chips, which is really kind of an old-fashioned way to do it, but I did it that way because it felt like cheating to do it this way. This way, what I've got, it's really very simple. There's just an Atmel328PB chip, and these are all WS2812 addressable LEDs, so there's only one pin really besides the inputs on that chip that's doing anything to control all those LEDs. And it's so easy, it just works. This is a DS1307 chip, a real-time clock that's keeping the time when it's unplugged. This is a major accomplishment for me, as small as it might seem, because all of my clocks in the past, they didn't keep the time when they were unplugged, but this one does. It's got that little coin cell battery in there that does that. I put this cover on the back because I guess it's illegal now to sell an electronic device with a coin cell battery that's not secured, so that nobody can eat them. But yeah, in this video, I'll show you how I made this and how to make your own. And I'll open source this. I'll make a page on my website for it so you can download the board files and the firmware and make your own if you want to. And unfortunately, I'm all out of these chips, the Atmel328PB. I've got more on order, so when they get here, I'll make a bunch more of these, and you can buy a complete assembled working clock right out of the box if you want to. They'll be pretty modestly priced because there's not a lot to them. They're pretty dang easy for me to make. So with that, let's get into it. I'll walk you through each step of the way. I'll show you the schematic and I'll show you the board layout. And then the cool part, I have a whole SMT assembly line here in my office just to my left. And so I'll show you each step of that. Not in detail to the point that you could learn how to do it, but I'll just give you an overview of how I use it to assemble this clock. You're probably thinking, how on earth do I understand the time on this thing? So it's just as simple as a little bit of math. It's not that bad. I think it's kind of fun to figure it out. It gets easier over time. You can see the columns are numbered, or the rows are numbered 1 through 8. So all of those bits there represent 1. If it's green, it's true. If it's red, it's false. So these are hours, that's minutes, that's seconds. So the hours, both of the ones are on, so that's 1, 1, 11. The minutes is 0, so it's 11, 0, and then 4 plus 1 is 5, so 11:05, and the seconds, I don't know, it's hardly worth bothering with. But essentially you just add the binary digits in each column together, and you get a 0 to 8 number. So this is my schematic in KiCad. There's not much to it really. All it is just a microcontroller. Here's my Atmel328PB, and the time is output on these addressable LEDs here, and they're just in a chain. They're all addressed from address 0 at U1, that would be LED 0, all the way up to U20 would be address 19, and the firmware will know how to tell each of those what to do from just that one single data bus. It's pretty dang genius. So in terms of other equipment on here, this is cool. This is a DS1307 chip, and that's a real-time clock chip. It's got a battery cell connected to it that doesn't do anything else. It just powers that. And so when this thing is powered off, it can keep the time. And that's its crystal oscillator right there. A couple of decoupling caps. That's my programming header. That's a pull-up resistor that's needed for the programming setup. This will be a 12-hour, 24-hour selector switch, because why not? I've got plenty of pins. Only using really one pin to output all those light LEDs. And switches, push-button switches to set the time. Need some pull-up resistors for the DS1307. And this is the USB power input with these two 5.1 k ohm pull-down resistors here. What those do is tell a power delivery charger that, hey, I want 5 volts. And it's just as easy as two 5.1 k ohm resistors. I use that trick all the time. That's handy. And so that's what the schematic looks like. Here's the board layout. This ended up being smaller than I intended, but by the time I realized that, I had it all done, so I went ahead and ordered it anyway, and I'm pretty happy with how it came out. in spite of being small. I ordered this from JLC PCB. How to order boards from a board house. I won't cover that. There's plenty of other tutorials out there on how to do that, but this is just a plain old 1.6 millimeter lead-free hot air solder leveled board. And yeah, that's about all I can say about this. So let's get into assembling it. So this here's my solder mask printer. What this is just an alignment jig. I'm truly missing the part about it that's a printer. It's an alignment jig. You order one of these framed stencils from JLC PCB, mount it in here, and it's got these really precise X, Y, and rotational adjustments so that you can line the stencil up perfectly with the board. It really works well. You can see I've got a board in there, and I have to order it with these little tooling holes, which I cleverly concealed under the buttons. So you can have quite a high throughput of boards through this thing. Just pop it in there, and holes are lined up perfectly. I like to use this Chip Quick solder paste. This is bismuth and tin and 1% copper, I think, and 137 degrees C is its melting point, so pretty low melting point. It's pretty forgiving stuff. So I'm just going to squeegee some of this in here. This thing came with a tool for this, but it didn't work that good. It was kind of rigid and kind of bent from the factory. So let's take this out and see what we got. Look at that. Perfectly solder pasted. So now I can put this in the pick and place, and we'll place all the components. So I've got the board in the YY1 neodymium pick and place here, and this will be the very first shot. We'll see how this goes. Usually what I've found with this thing is it takes me 1 or 2 go-arounds to get everything ironed out and running smoothly. So odds are I'll have a part that gets placed in the wrong position or upside down or not at all, or a feeder that gets jammed or something stupid. And it takes 1 go-around to iron that out, but I'm hoping this will work on the first try because I am running out of those 328 PB chips. There it is right there in a bulk type feeder. So let's give this a try and see what we get. It may or may not work on the first try. I'm going to press play there. Looks like we're starting with an electrolytic cap. Well, it missed the first part. There, it got a cap. I just love watching this machine work. All I'm going to do is put that in there, slide it shut, and press start. And this will take about 5 or 6 minutes to run. Oven is done. Let's see what we got. Yeah, looks pretty darn good, I'd say. I don't see any bridges or parts in the wrong place or anything that jumps out at me. So I could go through a bunch of hoops to machine solder this battery on the back. That's for the real-time clock, but it's not worth it. I'm going to hand solder it. So I'm going to do that, and then we'll flash the firmware and see how it goes. Now I'm here at my computer. Let's flash this firmware and see if this thing works. And I also soldered this CR2032 battery on the back. That's for the real-time clock chip so that it can keep the time even when the clock is powered down, which will be a really nice feature if I can make that run. So this is my flasher tool here. I'll tell you about it before I flash it. It's just an Arduino Uno. If you go to the example sketches in the Arduino IDE, there's one called Arduino as ISP. And what this is doing is allowing me to use this USB to UART or serial, I'm not sure what the protocol is, that talks to the 328P chip. but this 328P here on the Uno, it's got that Arduino as ISP sketch on it, and then in that sketch, in its comments, there's instructions on how to wire this up. So it's just 6 simple wires, and I think this pin 10 goes to the reset on the target microcontroller is really the only thing that isn't obvious. So anyway, I've got these little spring connectors so that I can press this guy up against these one-sided only solder pads on the target. And first I have to burn a bootloader, so I'm going to do Tools, Burn Bootloader. And I can see those lights flashing on the Uno. That tells me it's working. Now I'm going to do Sketch, Upload using Programmer. This program, by the way, or the firmware, it's totally AI written. Unfortunately, I used to have a really good friend. He was into coding and I'm into hardware. He would write my firmwares for me, but he passed away all of a sudden out of the blue. But ironically, AI came along and it's able to write code that I would never otherwise really be able to write, which is phenomenal because I can crank these things out really fast. Alright, I saw lights turning on while this thing was facing down. Here's the moment of truth. Will it work? It's not doing anything, and right away I realized the problem. It's not incrementing, but I think I assigned a capacitor to the spot where there's supposed to be a crystal in the pick and place. Oops. That would explain why it doesn't increment. Okay, that should reset the value to 0. This should increment. Hey, look at that. I think it's going to work. I just need to put a crystal there. Yeah, this is exciting. Okay, I'm going to change that capacitor out for a crystal. That's a big face palm on my part. Not sure how I managed that. Probably fat-fingered the feeder lane next to the crystal off by 1 digit and put a capacitor there, but fortunately that's an easy fix, so I'm going to swap that out and we'll see if this works. Okay, got that capacitor swapped for a crystal, and here's the moment of truth again. Look at that, it's counting up. I think it works. Let's see if it'll retain its value after a power down. So that is 4:13 and some seconds. Unplugging it, and it works. Hey, all right. I have tried for years to figure out how to use that chip, and I don't honestly think I would have got it in a lifetime without the help of my friend that passed away or AI to code it for me. Hardware is more my thing, not the programming. But man, I can crank stuff out fast with AI and these WS2812 LEDs and a microcontroller and this reflow setup here. So there you have it. That's the finished product. Could maybe adjust the brightness of those LEDs a little bit. They're a little bit too bright. This gets a cover on the back here too. As I understand it, there's a new law that says you can't sell a product with a coin cell hanging out like that, so I made this a cover. I do intend to put these in my store, but again, I'm out of these microcontrollers at the moment, so that'll be a bit when those come in. I'll make some more of these, and I'll open source it also, so if you want to download my board files and firmware, you're more than welcome to make your own. I'll put a link to my website where I'll put that in the description. Thanks for watching, and please like and subscribe.